Bismillah ar-Rahman ar-Rahim. Students, this is October 2025 and variant 45 mechanics complete paper we are going to solve today. So let's try to do it. Question number one we have, students, and this question is what we have: coplanar forces, magnitude P and Q 32, 21, okay, in directions given, and forces are in equilibrium. Equilibrium means rightward force is equal to leftward forces, upward is equal to downwards. You can short story Rx, Ry equals to 0. So we have to find out a P and Q. So first of all, resolving forces. So this one force acting this x-axis, this is a 47 degree, and one force I will take this way. So this is a force 21 and cos 47 degree. 47 degree. And what about this 21 sine 47 degree? And what about this 32 and angle 35? So I will make this left hand side and upwards. So this angle is 35. When angle given, that is cos component. So 32 cos 35 and the above one 32 sine 35. I think clear. And what about this 65 Newton, sorry, angle and Newton, skew Newton? So I can say here one acting left side and one acting downwards. Because I consider this 65, so this angle is this force cos component. I can say Q cos 65 and Q sine 65. This P is acting along x-axis, no component breaking. Now I can make two equations. Okay, and first equation, I'm going to make it horizontally. If I compare horizontally, okay, so right side forces is 1 and 2 and 3 and 4. Right side equal leftward forces, we can get two equations from here. You can see clearly. I'm writing here P plus 21 cos 47 and equals to this right side forces equal to left side forces. So I can say Q cos 65 and plus 32 cos 35. Okay, 35, 65, and 47. So I get one equation from here. So when I talk about vertically, so these two forces acting upwards and this force acting downwards. So I can say clearly that Q sine 65 is this, I mean, this force is basically equal to sum of the top two forces. So 32 sine 35 and plus 21 sine 47. Equation number two. And this is simply will go down and I will divide. When I will divide, I'm going to type simply in calculator. So 32 times 2 sine 35 plus 21 times 2 sine 47 and divided by sine 65. So when this will divide, so we get here, let me check in calculator. So I will get here Q value. After dividing, Q will become 32 sine 35 plus 21 sine 47 and divided by what, students? This sine 65. And answer I'm getting here 37.198 newtons. After rounding, I get Q angle is Q force is 37 point because I don't want, so add one. 37.2 Newton. This is my first answer. And this value, I'm going to plug in it here and get the answer. So this force will subtract. So I'm saying put in 1. So when I put in 1, so what happens, student? P is equals to, I will not put this one, student. I will use without rounding. So this force, I'm going to plug in it there. So 37.198 time to cos 65 plus 32 cos 35. So this value, I'm going to plug in it here, and this value will go and subtract. So negative 21 cos 47. So if I type in calculator, so this is plus 32 time to cos 35 and negative 21 time to cos 47. My answer is turned to be 27.6114. And after rounding, and I don't want 27.6 newtons. So Alhamdulillah Rabbil Alameen, the question number one is completely over. So question number two, we have students, what a question we have, if you read carefully, that an athlete runs along a straight horizontal road. So he starts from rest, okay, and accelerate 0.5 and reach a speed of v, okay. So it means, okay, it means if we show that this some idea, so accelerating, yeah, and get a speed of v, and how much time, not mentioned at all, and then it maintains this speed for v meter per second for how much time, t seconds. So it means it will continue, and here, so this time is from here till here is t second. So I just make a, okay, and this is also, this is a, okay, and then before decelerating at point 2. So it means this is acceleration. I am writing here a is equals to 0.5. Okay, and then he's saying point 2 deceleration, come back to the rest. So it means mm, this. Okay, make sure one more thing, very, very interesting. If a bigger acceleration, so this gap is smaller. If a smaller acceleration, so this gap is more. This is a one more technical point, but not that much important, but still it must be in your information, your knowledge. So let's talk, it means this acceleration is deceleration, how much? A is equals to negative 0.2. Okay, and this time is t is very clear. Let me check it from here to here t, and I count this is a t1, and I take this as a t2. Okay, and he mentioned that total cover distance is a 1350. It means area of the full trapezium is 1350, and total time is 246. So this point is 246. I can say that T1 plus T2, T1 plus T2 and plus T1, this all time adding is 243. So I think idea is very clear. So I can add now T1. So T1 plus T plus T2 is equal to 246. So this is very clear. Now thing is how we can find T1, because what are coordinates here, students? Coordinates here is T1 comma V. How come? This is X and this is Y coordinate. And what is 0, 0? If I apply the gradient formula, so what is the acceleration formula? Y2 minus Y1 over X2 minus X1. So I'm getting here V minus 0 over T minus 0. And acceleration is how much? 0.5. 0.5 is means 1 over 2 and V over T. Cross multiply, T becomes 2V. So this T1, sorry, this is a T1. This is a T1. This is a T1. T1, T1, and T1. So this T1 replaced by 2V. By 2V. And this T as it is, no replacement. And now let's talk about T2. Basically 0.2, if you check in calculator, it give you 1 by 5. Okay, what are coordinates here? This is okay. This is the difference of the times. Okay, I can tell you what is the velocity here. Velocity is 0. What is the velocity here is v. How velocity we can see from here. And what velocity here? 0. And I just label here P and Q. Okay. And what is our formula of gradient? Y2 minus Y1, or you start from here, Y2 minus Y1. So 0 minus V over x2 minus x1. So Q minus P. Q minus P means this difference, and this difference is basically T2. So I'm writing here T2. So minus V over T2. And this dissolution is negative 1 over 5. And negative cancel from both sides, and T2 become 5V. So T2 is coming 5V. So I can put it here 5V. And if you look at carefully, students, so 5 plus 2, 7V. So T is equals to 246 minus 7V. Now, students, he has mentioned already the distance, total distance 1350. So area of the trapezium formula is half time to h times 2a plus b. And if you look at carefully, students, trapezium formula, this gap is representing h equal to v. We can see from here. And this length is basically is a 246, and this is basically t. So I can write here. So I'm replacing the distance 1350, 1350, and h is v, a value is t, and b value is 246. 2 multiplies there, and I can get a 2700. So I got a V here, and V and T value is this. I can replace in the bracket. So 246 minus 7V, okay, and plus 246. Now V multiply inside, so 2700. So 246 and 246 into 2, you can see is 492. So 492V and minus 7V square. So I will bring both value left hand side, and 7V square positive negative 492V and plus 2700 is equals to proved. So we have done it. Alhamdulillah Rabbil Alameen. You can see it's match. So Alhamdulillah Rabbil Alameen, first part is completely over. Now second part, he said find the value of V and justify your answer. And I will apply here quadratic formula, and you know it very well. 492 plus and minus. At least as a teacher, I say you must show this formula for A and C over 2A. So if I apply this formula, and I will get two answers. So V value, I'm getting two answers. One value is coming with me is 6. And second, I'm getting here 450 over 7. Or I can say 64.2, 64.28. I hope so the point is very clear. And let's see how we can complete it. So how to justify your answer? There are two ways, but best way to justify is this equation. So if your time get positive, for example, if I plug in 7 here, so this time, so you can find it here. So if I plug in this 6 in the place of this, so let's see what answers turn. 242 minus 42, the time is coming positive. So it is correct answer. But when I plug in this value there, students, it is giving us negative. So 242 minus 7 times 2, 64.28. So I can tell you even 7 times to 64.28, and I'm getting here negative answer. So negative answer I'm getting from here. So this ignore. This I will not take it. So justification that this time is coming negative, so I will ignore it. And I hope so the concept of the question is completely over. Question number 3, we have a car of mass 800 kilogram is moving on straight road, and the car is moving with a constant speed of 2020 on a horizontal track, and engine is working with the power of W. So information given, when car is moving constant speed of 12, speed is change, okay, but is inclined angle, this one angle given, and the power engine is a P working, same power. So on both sections of the road, constant friction is R, okay, and we have to find R and P. So let's try. So basically, if you look at carefully, students, so this is a situation. So if the particle is moving from here, so right side is a force, backwards is a frictional force, and if the particle is going here, this applied force, and backward is a frictional force, and one more component mg sine theta. You know it very well. And this angle is given by him is, let's say, given alpha name. Alpha is equal to that. So alpha is equals to sine inverse 0.15. If I bring this here, so sine alpha is basically equal to 0.15. Okay, I'll make two situations. First, to horizontal. When you talk about horizontal, what is the formula? And is the net force equals to MA. Net force is equals to MA. So applied force minus friction force, I can write capital F minus small f is equal to MA. Okay, mass is 800. Applied force, we have a formula, power is equal to FV. If I make a F subject, so what will happen? We will go down. So F is equals to P by V. So this formula I'm going to use here. So P by V, okay, and V is given horizontal track 20 to 0, and friction force we label by capital R, and mass is 800, and acceleration, because constant motion, so acceleration is 0. So, and then if I multiply into 20 to 0, so 20 cancel out, I get a P minus 20R is equals to 20R is equals to 0. I got one equation, make a P subject. So 20R is equation number 1 done. Same formula, same the way I will go for inclined plane, net force equals to MA. And because system is moving upwards, so motion upward, I'll start from there. Capital F minus friction force minus mg sine theta is equals to MA. But again, because constant speed, you can see is clearly mentioned constant speed. So acceleration is naturally 0. And power force replaced by P over V, and V for the inclined plane is 12. So I'm writing here P over 12. Friction force represented by capital R. Mass is 800. Gravity is 10. And sine theta replaced by 0.15 is equal to 0. Okay, now again, okay, I can do one thing. So this P replaced by 20R, okay, and or first I simplify what I get 800 times to 10 and times to 0.15. So I get this 1200. So P by 12 minus R, and here I get negative 1200 is equal to 0. So P value is 20R. I'm going to replace here. When I replace 20R here, so I got 20R. So 20 divided by 12 will give us 5 by 3, 5 by 3 and 1 subtracted. I got 5 by 3 and minus 1. So 5 by 3 minus 1, I get a 2 by 3R. 2 by 3R and 1200 go on the other side. And from here, I can get easily 1200 into 3 divided by 2. And I got R value, friction force is 1800 Newton. So I hope so the concept is clear, and let's go for I got P value. So this value, plugging it here. So times 220, and I can say 36,000 is a power. But this is a watt, and I will convert it to kilowatt. And I did not mention at all, but I can write it here, 36 kilowatt. Okay, so this is my answer. I hope so. The concept is very clear, and let's go for next part. And next part we have here on the next page. Next page, the part is next is find acceleration of the car when the moving is a 10. Okay, up the inclined plane of the road is given. So it means acceleration we have to find. Let me write acceleration is a question mark. Velocity is 10 up inclined section of the road, and the power is given here 32,000 watt. Okay, and same situation we have, students. So this alpha is same, and the particle is now moving with a force, and backward is a friction force, and that is mg sine theta. Because system is not changed, condition is remain same. So power by V minus friction force minus mg sine theta is equals to ma. Okay, power is given 3200,000, sorry, and divided by what, 10. given by him speed 10. And with friction force, we got already friction force, and that is on the previous page. If you remember, friction force is 1800. 1800, we get already friction force. Okay, friction force is 1800. Okay, mass is 800 times to 10 and times to 0.15. Again, 800, I can get acceleration easily. So matter of typing in calculator, 32,000 divided by 10 minus 1800 and minus 800 and 10 times to 0.15. And I get here 200 and equals to 800A, and this double zero cancel out and I get a 104, or I can say 0.25 meter per second square. And the question is completely clear. So Alhamdulillah Rabbil Alameen, main part was here, and I hope so. The idea is completely clear of the question number 3. Question number 4, we have students a particle moving in a straight line, and after leaving O, the acceleration given by this formula, and K is a positive constant, and at time 0, velocity is 1. So important data is given here. T0, V is 1. Given that P never at rest, it is given already, not to ask, it is given that. Rest means velocity cannot be 0, okay? So it means, okay, it is very clear, velocity cannot be 0. So first of all, I have to use this data and find out expression of the velocity. So acceleration, I have it. This is a question of kinematics. If you remember this information, when we have a displacement, 3 levels we have. If we differentiate, we get velocity. If we differentiate, we get acceleration. So differentiate and differentiate. But if you want to come down, integrate and integrate. So right now I'm on a level of acceleration and I'm looking for velocity. So I must do integration. So let's start integration. So integration of acceleration will give velocity. I'm writing V is equals to integral sine kt minus 3 and dt. And student, what to do? Increase the power by 1. So 2, 1 power already, and 2 by 2. And negative 3 become 3t and plus c1. Okay, now after this, what to do, students? I will plug in data. Data is T0, V1. When I plug in 1 here and this 0 and this 0, so C1 becomes 0. 1, sorry. This plug in back here, I got a pure expression of velocity, K over 2t square, negative 3t and plus 1. But now story is what? Velocity is never at rest. It means this is a velocity expression, and if I ask what is A value is K over 2, B value is negative 3, and C value is 1. Basically, we have discriminant concept. If this idea, one concept, second concept, and this. So in this condition, B squared minus 4AC less than 0. Here, B squared minus 4AC equal to 0. And here, B squared minus 4AC more than 0. But when you say no solution, it means no rest. No solution. So we'll take this kind of idea. So it means discriminant is less than 0. So it means no solution will come, means no rest. So I can apply this story here, and B squared minus 4AC less than 0. Apply here. So I'm getting here negative 3 square, 4 times to A with a K over 2, and C is 1. I'm getting here 9 negative 2k less than 0. Okay. And we have to show this one k is more than this one. So I think we close. So I bring 9 on the other end, negative 9. And when I divide by negative 2, you know what happens, student? Divide by negative value. So look, I show you what I'm going to say. Inequality sign will change. This is a rule of division. And I got a 4 over 5, 4 over 2. 2 cancel 9 over 2, sorry, 9 over 2. Because basically, look at here, we got a 4.5. 9 over 2 or 4.5, same thing. So, Alhamdulillah Rabbil Alameen proved. So, part first, we have done Alhamdulillah Rabbil Alameen, and you understand very well the concept that is never at rest. Part number 2 He's asking the find distance, if k value is 2.5, find distance traveled from 1 to 3. So we are looking for the expression. So first of all, this equation, this one, I'm going to copy from here. I need a next page. Okay, so let's start. All right. And now we can see here clearly, but he said k value is 2.5. So 2.5, so 2.5 and divide by 2 is become 5/4. I write in fraction form. So velocity become 5/4 t square negative 3t plus 1. And now what a question we have, students. So instead the case, this one find total distance traveled from 1 to 3. So most important part here, as you know, the particle is never is not at rest. Not rest means its velocity will come here 0. It means maybe some distance above and some distance below. Then we have to care about it. But now current situation, it is very clear. There's a no velocity is 0. So we have to find distance from 1 to 3. Okay, so let's try to do it and check it now. How it possible to get the answer for this part? Okay, for area part, we have to find out the area part. Okay. So first of all, if it's important here, I will integrate because you know variable displacement, next level velocity, next level acceleration. If top differentiation, if coming down is integration and integration. Okay, and now it means we are level of velocity. I have to come down, so is again integration. So I get S is equals to integral sine 5/4 t square negative 3t plus 1 dt. And if I integrate, increase the power by 1, so t square already power 3 by 3. And this increase the power by 1 divided by same. So divide by same, sorry, and plus t plus c2. So if you look at carefully, students, so I'm getting here 5/12 t cube minus 3t square by 2 plus t and plus c2. Now, students, we have to find out the c2. And common sense here, because I said before, it's not at rest any position, so we can find out directly limits. Okay, but thing is here we have to just check it once again. What is the situation for this equation? Okay, for especially this one equation. Okay, because situation is changed. The situation is change. Now we will check it if the stop somewhere, because sometime in the, according to previous part, it is not, as I said before. So this is a positive and this negative. So it's surely not stop. But here we'll check it. If we get a velocity, does the particle stop or not? We have to check it. And for that reason, I will check. If I plug in velocity 0, I can get the time from here. So when I plug in here, just I stop here. So V put is equal to 0. When I put V0, 5/4 t square negative 3t and plus 1. Okay, and equal to 0. I'll apply the formula, quadratic formula, negative b b square minus 4a into c over 2a. So student, let's try it. At least this step you need to show to examiner, at least. Okay, then we can apply directly in calculator, no problem at all. So a value is 5/4, b value is -3, and c value is 1. So when I check it, I'm getting here two answers. So T1 is becoming 2.5. No, wait a minute, 2/5 is 0.4, 0.4, sorry, 0.4. And second time I'm getting here 2. So now I think you people understanding very well. So 100% the condition is what? It means from bit 1 to 3, 1 to 3. So it means this time I will not take it, it stop in the middle for sure. So it means that we have to, situation is like this. I can show you that there is a condition from 1 to 3. So maybe what's condition we can say here, we can plug in some parameters and get easily. So for example, I can check it and get it. Okay, just make a rough velocity time graph, but not full, just roughly. Okay, I will keep my eye here. And 1, I will starting from 1, and then I plug in 1.5, then 2, and then 2.5, and then 3. So when I plug in these sum numbers inside, okay, so let's see what answers turn to be and what I get the values. And if I plug in 1, so what I get a negative value. So it means when I plug in 1 here, I'm getting here negative 0.75. And when I plug in 5 upon 4 times 2, 1.5 square, and negative 3 into 1.5 and plus 1. So I'm getting again negative number, but negative 0.7 you can say. Okay, 7 plus 6, 8. Now we can say, 6, 8, we can say also. Okay, just a minute. Let me make a more clarity so people can understand. So I'm going to 7, 5 here. 7, 5. So 1, 1.5, 2, 2.5, and 3. So here I get a negative 0.7, here negative 0.68. And against 2, what I get? Against 2, if I check in calculator, against 2, this is just roughly because this is not required to answer. So I'm against 2, I'm getting 0. Against 2.5, when I check it against 2.5, so the answer I'm getting here, students, is 1.31, 1.3. And against 3, what I can check it now, against 3. So these values are compulsory to check, and I'm getting here 3.25. So if I focus here, so students, first, this is 1. Okay, just make of understanding 1. Or I can say here 1, here 2, here 3. 1, 2, and 3. So 1 is negative here, and 1.5 is negative, and 2 we got a 0, and then I got a positive, and this I got a bigger number. So basically the curve is coming like that. So if you look at carefully, this is a negative and this is a positive. So you can see that it is a 2 in the middle. Okay. So you can see that the some area is below and some area above. So now I can say very clearly, students, the same expression I will use, but for the negative, because, and you know very well, when it's below x-axis is area will be negative, and this area will be positive. So what I will do, students, now I have this integration done, and this c will come naturally 0. C will become naturally 0. How I got it? Because we mentioned the previous part, it start from rest. So when s is 0, t is 0. So when 0, 0, 0, and 0, so C2 becomes 0. And I got a pure expression 5 by 12 t cube minus 3 by 2 t square plus t. So this is my pure expression of displacement. And now I'm going to do what, students? Basically, I'm looking for, I will plug in some numbers and get the answer. So basically, I have to find first 1 to 2. 1 to 2. So same expression, I have distance and limits. I will plug in 5 over 12 t cube minus 3 over 2 t square plus t, and limit 1 to 2. And this answer will become negative. So to eliminate negative sign, I put outside negative sign. Okay. Or I will eliminate negative sign later on. So let's try to do it, students. So 5 divided by 12 times 2, 8, minus 3 or divided by 2 into 4 and plus 2. I'm getting here negative 2 by 3. Upper limit done, minus. Now when I plug in 1, students, so 5 over 12 minus 3 over 2 and plus 1, I get negative 1 over 12. So S becoming from 1 to 2 is what? Negative 2 over 3 and positive 1 over 12. And I'm getting negative 7 over 12. I said before, so this negative I will eliminate later on. Now 2 to 3. 2 to 3, same situation I will use, same condition I will use, but I will use what, students? Okay, I will use not 1 to 2, 2 to 3. And this will give you 100% positive answer. So when I plug in 3, okay, let me check. 5 divided by 12 into 27 minus 3 divided by 2 into 9 and plus 3. My answer is 3 by 4 minus. So when I plug in 2, and you know it very well. It give us negative 2 by 3, but still I check. 5 divided by 12 into 8 minus 3 over 2 into 4 and plus 2. I'm getting here 1 to 2. Wait a minute. Once again, I check it. 5 divided by 12 into 5 by 12 into 27 minus 3 out of 2 and plus 3. I will check once again what I get. First part is okay. And second part, I'm typing once again. Okay. Let me check 3 or 2 or not. Yeah, 3. Okay. Now, once again, 5 divided by 12 into 27 minus 3 out of 2 times 2, 9 and plus 3. I'm getting 3 by 4 is the correct answer. And now I plug in the other one. 5 divided by 12 into 8 minus 3 divided by 2 into 4 and plus 2. So this answer is turned to be negative 2 by 3. And 3 divided by 4 plus 2 divided by 3, this answer is coming positive 17 by 12. So student, what is total distance? We can say as a total distance traveled is this negative sign I will eliminate. Okay, I got a 7 out of 12 and plus 17 out of 12. So when I get it, so I got what student answer finally? 17 plus 7, 24 out of 12. So we got final answer is 2 meters. So this part was a little tricky, and main part is only tricky is what? Because the below and above. This diagram is very important. Otherwise, without diagram, how you know, we come to know which part is above or which part is below. So whenever distance is question mark, you are bound to plug in velocity 0. And when you plug in velocity 0, you can come to know easily that which point in the given domain the values particle stops or not. So this is the whole story. I hope so. The concept of the question is completely clear. So question number 5 we have. Read a question. The diagram shows a particle P of mass 5 kilogram. So 5 kilogram, so 6 kilogram here mentioned clearly. And the plane inclined 30 degree, you can see clearly. And most important part is what here, the two particles, one 5 and one 2 kilogram, and hang vertically. Both strings start and the string release from rest. It means the particles start from rest, means starting velocity is 0. And tension string in Q is twice. This is a main point here as compared to R. So whatever tension in R, let's start from R. So let's assume this is T1. So if there's a T1, so what is this mass? And what he's saying further, so in terms of G, so normally we put a G value is 10. Okay, but he said don't put 10. So give us a value in terms of G. So mass is a 2, and normally we write 2 times 2, 10, 20. But he said no, write it as a G, so 2G. So this weight is a 2G. And tension in upwards T1. And you know this tension always equals to each other. So T1 and T1 equal. And what about this one, students? Same story, 5 into 10, not 10, 5 into G, I got a 5G. And this I count as a T2, but he said that the tension if Q is twice and at R we have T1, so this naturally is a 2T1. Reason is twice. So this is also 2T1, double of that. Clear? And now what is the next part? He said in terms of G, the tension of each string and magnitude of acceleration of particles. So let's try to find it. So how we can start it? Let's start. So first of all, because heavy particles here, lighter particle, so common sense, it will fall down, it will go up. So I'm starting from the particle, this one. So let's try to make a formula here. And you know, net force is equals to MA. So when a net force is equals to MA, net force is equals to MA. So this, because system is moving upwards, a bigger force, tension 1, this is a smaller force. So I'm writing it now below here. So for R particle, so T1 minus 2G, 2G is equals to MA, and mass is a 2 and acceleration is A. I got a first formula. And let's try to do the second one when we talk about this particle. What situation we have? If we look at carefully, 5G, I'm writing here Q. So 5G minus T to 2T1 is equals to MA. And what is up? Sorry, I did not write mass here. I should write here 2A because mass is 2. And what about a second particle? Same formula used for this particle, but it is moving downwards. So this is bigger force. I'm starting from here. And this is smaller force. I'm writing later on MA. 5 times 2A. I hope so. The point is very clear. Now we have to find the G in terms of G, what we find it, tension, and we find out an acceleration. So we will what? We will try to first cancel acceleration or cancel tension. Both are okay. All right, so this 2 here, and we don't need 2, we need 2 here. So multiply upper equation with 2. So 2 multiply with each number, each value. What I get here, 2t1 negative 4g is equals to 2 to the 4a. And here I'm getting 5g as it is, negative 2t1 equal to 5a. And you can see, students, this both values will cancel, okay? Cancel like this, and out of 4 and this 5 gone, I got a G, and here I got a 9a. So acceleration, alhamdulillah, I got a 1 over 9 times 2 G. So this, he asked us to find acceleration in terms of G. So alhamdulillah rabbil alameen, we have done first part. And now I can put this value in any one formula. I think put in this formula. So put in the top one. So I could say here T1 minus 2G is equals to 2 times 2 acceleration, which replaced by this. So I'm writing here 1 over 9G, and this will go on the other end. So I can find tension from here. So this 2 by 9G already, and positive 2G, sorry to say this is a 2 over 9G, 2 over 9G and positive 2G. And 2 9 2s are 18, 18 plus 2 20. So I got a 20 over 9G. I hope so. The concept is very clear, and we have done so 20 over 9, and I got a 1 over 9. So I hope so. The point is very clear, and we got this 10, but he asking here tension on each string. So I got a tension in one, but I need to find second tension. So this is a tension. Now second tension is 2T1. So this is, I will call as R. So tension in R. So I'll call as a tension in R. Now tension in Q string, like that particle which is a Q due to Q. Okay, so that is a naturally I can say, so this multiply into 2. So I got what, students? So 2 to the 40 over 9G. So alhamdulillah rabbil alameen, we got both tensions because he said that each tension string and find out the magnitude of acceleration. We have done it. So first part of 5 marks is over. Let's talk about second part. Second part, on the next page, we have find the coefficient of the friction of P and the plane. Okay, 5 mark question. Coefficient, we need to find it. So let's try to do it. Okay, when you talk about this one, I did not utilize up till now the particle P. And luckily, I have both tensions available. This tension value, I have it, and this tension value I have as well. But you know, system is moving downwards, so I can tell easily this is moving downwards, and it, how many forces acting on this particle P? So this is acting downwards is a mg weight component, mg sine theta. You know it very well. Okay, and because system is moving downwards, so friction will be backwards. This is a frictional force. Now, students, so this concept I have to make on next page to continue. Okay, and I make this diagram. So this is a very important. Okay, so this is a particle, and it has this is a it is a 2T1. 2T1, if you check it carefully, 2T1 is what here? 2T1, this is a the tension 40 over 9G. So this I can tell you this is at 40 over 9G. This is a second tension, and this is a weight component. This weight component I mentioned here, mg. Okay, I can write it now, mg. And what is the mass? 6. I can tell this is a 6g sine theta, and theta is 30. So this 6 sine 30. and backward is acting friction force. This is a friction force, and then one more is a tension T1, and that tension T1 we have already 20 by 9, 20 by 9. So I can write it now here, 20 by 9 G. So system is moving downwards, so now I can find it easily. So try to shift this whole diagram from here, cut from here, and paste on the other page. So now we can solve it now. So have a look now, students. So, and okay, I write this weight component here. So this is a weight component of particle, and students, the system is moving downwards. You know it very well. Okay, but we have missed one part. What is that? This normal reaction, R. And what is this? Mg, basically it's mg cos theta, mg cos theta. Okay, but mass is what we have, a 6. So I'm replacing this m by 6, and theta is replaced by 30. So when I replace this one, okay, now I think we have everything. So I'm starting, okay, let's start. First of all, I can write this one as because sine 30 is half. So I can say this is a 3g, because half into 6, I got a 3g. This is a weight component. And what about this, which root cos 30? And cos 30, it very well is a root 3 by 2. So when I plug in here 6g times 2, root 3 by 2, root 3, but this is cancel out. And I got this component is equals to what, students? 3 root 3g, 3 root 3g. So this is a weight component. I think your idea is clear. Now let's talk about net force is equals to ma. Net force is equals to ma, because system is moving downwards. So this is a weight component, this is a tension, this is a weight component, this is a friction, this is a tension. I'm going to make it together. So 40 over 9g plus 3g, this come from weight component. And okay, how to find friction component? That's part left only, and I try to find it. F is equals to mu r, and r is basically equals to this. So this I'm writing, this I'm writing it here. So F is equals to mu r. Mu is unknown, and r is 3 root 3g. So I can write it now here. So because weight component, sorry, tension and weight component and minus friction and minus that. So friction force subtracting, I got a mu times 2, 3 root 3g, and minus 20 over 9g is equals to ma. And the particle mass is, 6. So 6 times 2 a. And acceleration, we have value, we have already value. If you go back and see the acceleration value, check it, students. The acceleration value is 1 by 9g, we have already. So 1 over 9g, I am writing here 1 over 9g here, 1 over 9g. All right. So students, now if you see carefully, G, 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 and G. So all, if I divide by G whole equation, I get 40 by 9 from here, 3 from here. I get 3 root 3 times 2 mu from here, and minus 20 by 9 from here. And 3 2s are 3 3s are. So this I get from it. Now simply I have to make this subject and I'll get my answer. This I bring on the other side because negative sign is there. 3 root 3 mu, and rest I all type together. So I'm typing 40 divided by 9 plus 3, and negative 20 divided by 9 and negative 2 over 3. I'm getting here 41 over 9. And if I divide this value by what? 3 root 3. So students, I get the exact value mu formula. Mu exact form is 41 root over 81. And if I write in 3SF, I get what? 0.8767. But I don't want, which I don't want bigger than 4. Yes, we add. So ultimately we got 0.877, which is our exact form. If we ask exact form, this is our exact form, and this is a 3SF. I hope so the point is very clear. Let's talk about part C. It is given that when the system is released from the rest, okay, and the P is at the midpoint, like release from rest, so it means starting velocity is 0. P is at the midpoint of the plane, so P is in the middle of the plane. I just show some idea here that this is a plane. 1 minute, I show once again. Inclined plane, whatever the distance. Okay, P is exactly in the middle here, and in the middle he said. So total distance, if okay, I can take this distance is, let's say, x, okay, to reach the pulley. Read a statement. In the subsequent motion, R does not reach the pulley. What is R? R is hanging here. You know it very well. Hanging here, and this R component, and this is another component. You know it very well. Pulley here and pulley here. All right, and this is R does not reach the pulley. The P is mean R will not reach the pulley. Okay, and this is travel downwards. It is traveling upwards, and this traveling downwards. He's saying that reach the pulley, okay, and P takes 1.5 to reach the pulley. So P will reach how much time? So this time, I am writing here, time reach the pulley is 1.5. Starting from rest, I'm writing 0, and distance I will count as a x. You can see clearly. And he's saying that find total length of the plane. Actually, he's asking full length. But he said that is a midpoint mentioned clearly. So if I find the x into 2, I'll get the full length. So x is my job. And luckily, acceleration is given by him 1 over 9g. So 1 over 9g is g is 10, or I can replace, it is a very clear 10, 10 over 9 even. 10 over 9. Okay, this is acceleration. So what is my job? I think it is very clear. So S is equal to ut plus half at square. So S is a job to find, U is 0, and acceleration is 10 over 9, and time is 1.5 square. It's a matter of typing in calculator. So two ones and two five times. So 5 over 9 times to 1.5 square. And I am getting here, students, 1.25, but you know this x comes from here into 2, so total length, he is asking total length. So total length of the plane is into 2. When I into 2, I got a 1, I got a 2.5 meters. I think meters. Okay, so I hope so the concept of the question is completely clear. Question number 6, we have two particles, A and B, of the mass given here. A mass is given km and B mass given m. Okay, fine. And we mentioned that both k and m are constants, are free to move in a straight and smooth surface. So it means no friction at all. Particle A is directed towards B and speed of 2u, and same instant B is predicted towards A with speed of u. All right. So I think first of all we will go to make a diagram. Okay, 1 minute, please. Just a minute. I make this diagram. Oh, okay. This is better. Okay, I can make it. Sorry to copy and paste. You know, students, this is A particle, this is B particle, speed, mass of this is a km, this mass m. This is going towards here 2u, and this moving towards here u. You know, students, we have a basic criteria. When a particle is coming from observers, look, it's very clear, is if the particle is going away from observer velocity positive, coming back to observer velocity negative. So it means this is coming back to observer and this going away from observer. So this speed we count as a negative. This is just before collision, and let's talk about after collision. And what is after collision? Let's take a look and copy and paste. So let's try to do it. This is after, this is before collision. After collision, the path speed of A is u, and both move in the same direction as originally A moving. Originally A moving is right side, so it means both will move right side. But this speed is given by him as u, we can see clearly, and this speed is we don't know. And read it further, it is given that 35% of total kinetic is lost in collision. Find in terms of u the speed of the B particle. So it means I have to find this x. I count this speed as the x, and my job is to find out x in terms of u. Okay. Uh, so find in terms of u the speed of the b after collision. So first of all, what to do, students? Formula m1 u1 plus m2 u2 is equals to m1 v1 plus m2 v2. So this criteria is very clear. You know in the formula law of conservation of momentum. So mass is this and speed is that. So I'm writing now here km times to 2u. But here m times to not u, negative u. Y is going back to observer and equals to, this is a km times to u speed. And mass is m, speed I don't know. So I think you can see clearly, students. So every particle, we have a mass available, so divide by m. So I got a 2 ku, 2 ku and minus u is equals to ku plus x. So this ku will come on this side and this come here out of this subtracted. So I can say that I have x is equals to ku minus u. So this is clear. It will go and subtract from here. Very clear. So this is a x value. We have it. Okay, I think clear. Okay, I need to find this x. And he said that find out in terms of u, the speed of the b, okay, after collision. But we have to find how, because it depends upon two things, k and u. All right, so let's try to do it, k especially. And what important part here, 35% of total kinetic energy is lost in the collision. So it means we must need kinetic energy before collision and kinetic energy after collision is a very, very important. So let's try to do this one, kinetic energy before collision. So I'm writing here before collision. What is the kinetic energy of before collision? So let's try to find it of both. So half mv square, formula is mass mv square. And what is the v? 2u. 2u if you find from here. And what the other one, half m v square. And your negative v, not a problem, is power 2 will turn it. So I got this value clearly. And if we check it carefully, you have km times 2 4u square. And what here? Positive half times 2 u square. And if you look at carefully, students, I think we cannot do anything because k is there. But I can simplify these two only. So let's try to simplify 2 km u square plus half mu square. Okay, done. This is before collision. So let's talk about after collision. After collision. After collision, we have data available here. So I'm finding kinetic energy after collision. So after collision, we can write here half mv square. M is km and v is what after u. So u square plus half into mx square. Okay, this is done as well. I think we cannot do anything extra from here because I cannot cancel anything. Anyway, I just write it simple format, half km u square and half mx square. So let me check. Yeah, clear. And this is before collision, this is after collision. And now listen up carefully. According to situation, what is said that if you read a statement, 35% of energy is lost. So 35% is lost. Um it means that if I just tell you one thing, 35% lost and what left behind, you can say that if 35% gone, look at here, student, out of 600, 35% gone, what left behind? 65%. So can I say, students, this is before collision and this is after collision? Can I say that the kinetic energy after collision is basically is 65% of the original? Yes, I can say that. Look, I'm writing here after collision, kinetic energy is 0.665% or 0.65. Same thing. This is because person means by 100 times to before collision kinetic, before collision kinetic energy. So this is a formula. I repeat once again, if this is the sentence, most important sentence is here. So after collision, whatever energy left behind is 65% left of the original one. So this is a original one, before one. So I think you can understand from here. Now this value, I'm going to copy it here after collision. So look, I'm just copy paste from here. This is a value I'm copying from here and I'm pasting here. This is done. Okay. And this I'm copying from here because this is a before. I'm writing now here. Okay. And here I'm writing 0.65 times this one. So I believe you got a point. This is before collision and this is after collision. And 30, because 35% lost, how much left behind? So you can say very clearly, so 65% of this is basically this much. Okay. Now students, what's the technique? If we look at carefully in whole equation, you have a m available, and just a minute here, m available, and yeah, important part here, we have to get rid of this section. This x, look at here, look, m same, but here u square, but only this x square disturbing us. Why we cannot replace this x squared by this and get rid of this one? So I think this part is very clear. So I am going to replace this part here. So get ready, students. So I am replacing this x square by its special value, and I'm writing in a blue color so you people can understand very well. X square, I'm writing here ku minus u is come from where, students? This x value. So I think now we can solve this easily because now we have only and only k, m, and u left behind. I think we can do easily. So first of all, I will do two jobs together. So divide by m. So m. Okay, this m will common out, will cancel out, throughout can cancel out. Okay, I can say half ku square. What about this? Here I'm using squaring identity. Let's try to open it. First term square, negative 2 into first term, into second term, and plus second term square. What about right hand side? Right hand side, students, we can do it 0.65 times 2. If I type it in calculator, so this multiply with that, I will get what here? 1.3 ku square. And what about the 0.65 divided by 2? So I'm getting here this multiply this one, so 0.325. So this is, okay, I'm writing 0.325 and u square. Now, students, I'm just going to continue from here. This half will multiply inside. I will get half k square u square. 2 cancel, and I get negative k u square. And I get here half u square and equal to 1.3 k u square. 0.325 u square. U square, u square, u square, u square. If I divide by u square, students, I will get what? Half k plus half k square minus k plus half equal to 1.3 k and plus 0.325. Now, students, a complete equation turned to be k format, and I'm writing now half k square comes from here. Now this half k and this negative and this 1.3. 1.3 will come this end. Basically, I'm typing like this in calculator. Half minus 1 and negative 1 over 3. This come from here and this negative 1 from, and this will, because negative sign is there. So if I type this in calculator, half into negative 1, negative 1.3. So I'm getting here negative 1, or I can fraction form negative 9 over 5k. And here k square I have already. Now, students, what left behind? The left part is only the numbers, okay? This number and this number. So this will go and subtract from there. 1 over 2 minus 0.325. And I'm getting here 7 over 40. 7 over 40 is equal to 0. And this equation, I got it. And now if I solve this equation, I think I will go for the next page. I'll copy from here and I paste on next page. And if I go here, hmm, yeah, so I'm going to apply formula. And formula is negative b plus and minus b squared minus 4a and c over 2a. And now students, if I apply, mm, uh, I'm applying, or I can equation, okay, and degree 2. And what is the first value? 1 over 2. Second value, negative 9 over 5. Third value, 7 over 40. So my first answer is turns to be k value is 3.5. And second value, I get k value is 0.1. So I hope so. The point is very clear. I got two values of k. And if you go back, and because he is asking in terms of you, the find of the, so this is a value k. So this I'm copying from here and pasting there because this copy and paste on the next page because speed of v in terms of u is my job. So I'm going to write it, paste here, so and paste here. Okay, now, okay, so I'm going to plug in this k value here. So when I put the k value here, students, so let's try to find it, what I get the answer finally after typing in calculator. Okay, so when I type it here, 3.5u minus u, it's turned to be 2.5u. And this is my answer, meter per second. Now, question comes, what is this value? Okay, what is this value? If I use it same here, so Ku minus U, okay? So I'm getting here 0.1 U minus U. So I'm getting here negative, students. So zero point 0.1 subtract 1, I get negative 0.9 U. But this is not possible. Why not possible? Because, according statement, he said before, he said that, read a statement, please. He said that they move, okay, both move in the same direction as origin. So both are going right side. If it is coming backwards, according to criteria, we must have a negative velocity. And I'm getting negative velocity. It means it's not possible. So it means this is not possible. And we got the right answer. Positive answer, right answer. We have negative. I will not take it. And I think so. The point is very clear. And paper is completely over. And best of luck for the exams. And I pray for you, inshallah. And if you have done some mistakes, please, after class, after watching this video, re-practice those questions where you found a mistake. Okay, and best of luck for Islam for your exam. Assalamu alaikum wa rahmatullahi wa barakatuh.